In this question, we need to determine the direction in which each one of these forces tend to turn the system about the pivot. This is the pivot. In which direction does the 12 Newton force tend to turn the system about this point? If we assume F1 and the 4 Newton force are not there, then the 12 Newton force turns the system clockwise about the pivot as shown. In what direction does F1 and the 4 Newton force tend to turn the system? Again, if we assume that the 12 Newton force is not there, F1 and the 4 Newton force tend to turn the system in the anti-clockwise direction about the same point as shown. That is anti-clockwise direction. Now this system is in equilibrium, so the principle of moments applies. The principle of moments states that the sum of the anti-clockwise moments about point O is equal to the sum of the clockwise moments about the same point. This is the point O. This one here. We have just seen that F1 tends to turn the system in the anti-clockwise direction. Similarly, the 4 Newton force also turns the system in the anti-clockwise direction. 12 Newton force, however, turns the system in the clockwise direction. So there are two anti-clockwise moments. That is why we talk about the sum. The first anti-clockwise moment about point O is due to the 4 Newton force. The line of action of the 4 Newton force is this one here. The distance from point O, which makes 90 degrees with the line of action of the 4 Newton force, is 12 centimeters. If we convert 12 centimeters into meters, we are going to get 0.12 meters. You will remember that to convert centimeters into meters, we just need to divide centimeters by 100. I need you to remember that. So the moment due to the 4 Newton force about point O is 4 times the distance 0.12. This is anti-clockwise moment. The other anti-clockwise moment is due to F1. That is why we are adding. We are adding because we are talking about sum of anti-clockwise moments. There are two anti-clockwise moments, so we add them up. So F1 times 0.08. Again, I get 0.08 by dividing 8 by 100 in order to get that into meters. That's all about the anti-clockwise moment. When we come to the 12 Newton force, it tends to turn the system clockwise, and the clockwise moment is 12 times 0.05. Of course, this one gives us 0.48. This gives us 0.08 F1, and this is 0.60. The mathematics is just that simple. So on the left hand side, we are going to remain with 0.8 F1. We take 0.48 to the other side, subtract it from 0.6, and that gives us 0.12. In order to get F1, we divide both sides by 0.08. So on the left hand side, I remain with F1 because I've divided by 0.08. The other side, I divide by 0.08, and that gives me 1.5 newtons. It's just as simple as that.